In this video, we're going to look at rational functions, simplifying rational expressions. Before that, we're going to look at rational numbers. So a rational number is a number that can be expressed as a fraction whose numerator and denominator are integers. An example of a rational number would be something like 10 over 6. Now, 10 over 6 is a fraction that we know can be simplified. So we're just going to kind of review this idea and see how it fits into what we're doing with expressions today. If I look at 10 over 6, I'm looking at how can I rewrite 10 and 6. So I could write 10 as 2 times 5, and I can rewrite 6 as 2 times 3. Because I do that, I can cancel out the 2's, right? The 2's would cancel, and I'd be left with 5 over 3. 5 over 3. 5/3 is the simplified form of 10/6. In the past, I haven't done it like this to get there. We may have looked at 6 and 10 and say, what can I divide them both by? I can divide them both by 2, and we would go ahead and do that, leaving us with 5/3. So 5/3. So this here is going to help identify what we're going to do today as far as that simplifying process. So again, I'm going to look now at a rational expression. So if a rational number is a number that can be expressed as a fraction with integers, a rational expression is an expression that can be written as a fraction whose numerator and denominator are polynomials. Something a little different, though, is values that make the denominator of the expression 0 are excluded values. So we're going to outline these as excluded values and include them in our simplified version. So looking at simplest form. When the numerator and denominator have no common factors except 1, it's considered to be in simplest form. To simplify, factor the numerator and denominator and divide out any common factors. So if I look at the first example, let A, B, and C be polynomials where B and C cannot equal 0. So I'm going to have algebraically a polynomial times a polynomial divided by a polynomial times a polynomial. If two of those polynomials are equivalent, they will cancel out and no longer be left in my simplified version. For example, here 2 times x plus 1 and 5 times x plus 1, the x plus 1 and the x plus 1 will cancel, leaving me just with 2/5. So let's see how this works in action. 12 divided by 2x squared. 12 right as 2 times 6, and 2x squared would be written as x times x. Now, if I look for what can I cancel out, I can cancel out a 2 and I can cancel out a 2. Nothing else between the numerator and denominator will cancel. This will leave me with 6 over x times x, or x squared. Now we talked about excluded values. So I'm going to look at this denominator and I'm going to say, all right, what value here squared would give me a result of 0? Because that denominator can't be equivalent to 0. And I come up with x cannot equal 0. X cannot equal 0 because 0 squared would leave me with 0 in the denominator. So this would be my final answer. Let's take a look at B. Can I rewrite n? No, I cannot, so it's going to stay n. Can I rewrite n plus 8? No, I cannot, n plus 8. Now, you might be thinking, well, the n's will cancel. The n's will not cancel here because I can divide n by n. I can do n divided by n. 8 divided by n doesn't work, so I can't divide the whole side by that value. So turns out this is actually already simplified. Now if it's already simplified, I wouldn't have to change it, but I would want to mention some values that n cannot equal. In this case, n cannot equal -8. -8 plus 8 gives me a result of 0. So I keep the original version, but I include the values. Let's look at C. The top I can rewrite as 3 times y times y. the denominator, I could rewrite the 6 as times 3. Then I have this y. And then I have y minus 7. Once I have it written as factors, I'm going to see what cancels. The 3 and the 3 will cancel. 2y's on the numerator, well, I shouldn't even say that. 1y on the numerator, just one, will cancel out this one. So just as I have to have it on the numerator and denominator to cancel, so this will still be a y. I can't cancel this y and this y because this one's stuck inside the factor of y minus 7. So my result on the top, the 3 was gone, the y was gone, but this y stayed, divided by 2 and then y minus 7. Now, this is a little tricky. If I look here, I have an excluded value. So this, if this is 7, so y cannot equal 7. 7 minus 7 is 0, and that's no good. But because these two are equivalent rational expressions, just like 10/6 and 5/3 were equivalent, they have the same value, what I have to do is I also have to check the original for any excluded values. So here I have the 7 covered. 7 I know is excluded. What makes this 0 if y is 0? 6 times 0 is 0. So y also cannot equal 0. So y cannot be 7 and y cannot be 0. So we're going to check our simplified rational expression as well as the original rational expression. All right, you can pause here and try the next 3 on your own, and then we'll go through them. All right, looking at D, I'm going to write out 5 times y times y times y. And then in the numerator, 2 times y times y. 2 y's will cancel 2 y's, leaving me with 5y over 2. That'll be my final simplified version. Now, here there's nothing that makes this 0, but if I go back to the original, if the y is 0, it will. So I'm still going to have to include that as an excluded value. Y cannot equal 0. Looking at E. 8x, I can actually rewrite that as 2 times 4 times x, and then x plus 1. And then in the denominator, I can write this as 3 times 4 times x times x. Now, if you're wondering, like, why did I do 8 as 2 times 4, not 8 times 1 or anything like that, I'm trying to think what's going to cancel out. So I'm kind of looking at the 8 and the 12 and saying, what can I divide them both by? And I can divide them both by 4. And you could do that without this rewriting process. All right, so the 4 and the 4 will cancel. This x and this x will cancel. Now, reminder, I can't do anything with x plus because it's in the parentheses. Will give me a final result of 2x plus 1 over 3 times x. X cannot equal 0, and the original x can also not equal 0, so this would be my final result there. And F. All right, m plus 1, I can't rewrite it. I can't factor anything out of it. The bottom is already written as factors, so now I just look for cancellation. Anything can cancel. Nothing can cancel. It's tempting. I want to cross out these m's. Can't do it. Even this m and this m can't do. So now I just need excluded values. So this is good, but m cannot equal 0 here, because 0 times anything is 0, so m cannot equal 0, and negative 3. And what we're kind of doing is we're kind of using zero product property in a different context. All right, if we look at the back side of our notes, something more complicated. So a little more complicated type rational expressions. These are often going to include something like a quadratic or just involve some more difficult factoring. Looking at A, I have 1 minus z squared over 1 plus z. In the numerator, we have a quadratic. That's actually a difference of squares. So kind of like our conjugate work that we have done, we write this using our difference of squares factoring. So this is going to factor into 1 plus z times 1 minus z. And again, that's just our difference of squares property. The bottom will be 1 plus z. Now in looking at canceling here, I have a 1 plus z in the numerator and a 1 plus z in the denominator. So I'm actually going to cancel both of those. And that will leave me with 1 minus z. Excluded values, I'm going to look in both spots. Now they're the same, so z cannot equal -1. Now, although it doesn't affect the original expression, like 1 minus -1 is just 2, it doesn't affect this, but in the original, we know z can't be -1, so we do have to account for it. B, all right, I got two quadratic polynomials. So looking at the top, I want to factor that. C squared plus c minus 12. It is a trinomial. It has an a value of 1, so I'm going to use the shortcut of what multiplies to -12 and adds to 1. It's going to be 4 and -3. So I have c plus 4 and c minus 3. The denominator will factor as well in a similar fashion. What multiplies to -20 and adds to -1. It's going to be -5 and 4. So c minus 5 and c plus 4. Looking at this rational expression and its new rewritten factors, I have a c plus 4 and a c plus 4 that will cancel. This is going to be a result of c minus 3 over c minus 5. Now this is my final result. Those won't cancel. Again, it's tempting to cancel the c's out, but we can't. Excluded values for c. Well, looking here, it's 5. C, that's not good. C is not equal to 5. And then taking a look back at the original, c can also not be -4. So we're going to account for both of those there. And C. C will look kind of familiar from the first one. So our difference of squares will on the top will give us 1 plus z and 1 minus z. The denominator is z minus 1. It really looks like something cancels, but none of these factors are equivalent. So this is actually my final version, but I do need to account that z cannot equal 1. 1 minus 1 is 0, so that would be my final result there. If you want to pause and try the next 3, you can do so, and then follow along for the results. All right, taking a look at D. Looking at the numerator, we have to remember some rules and some factoring that we can remind ourselves of. I can factor out a 2 out of the numerator. So that would look something like this. 2 times b plus 4. 2 times b plus 4. 2 times b is 2b. 2 times 4 is 8. The denominator, I can factor out a 7 of each term. So that's going to give me 7 and then b plus 4. Now taking a look there, it's kind of becoming a little more apparent of what we would cancel. The b plus 4 and the b plus 4. That's going to leave me with 2/7 as a final answer. 2/7. Now nothing makes this 0, but going back to the original, b cannot equal -4, because that will make 0. All right, Two more. Looking at E. I'm going to see what factors out of the numerator. In this case, I can pull out a 2. Leaves me with A minus 3. The denominator, now it is a quadratic, but it's a quadratic missing a term, so I'm going to see if there's something I can just factor out of it originally. I can pull a 4 out of both terms and an A. So if I pull out a 4 and an A, I'm left with A minus 3. The A minus 3 and the A minus 3 will cancel each other out, leaving me with 2 over 4A. Now 2 over 4 simplifies to 1 over 2 with my A. So 1/2 A. Or not even 1/2 A. It's actually 1 divided by 2A. So it's a half times 1 over A. So we can't say 1/2 A. A cannot equal 0 here and here, right? Both of those are 0. And A can also not equal 3. 3 minus 3 would make that 0. So we have that as our final result there. And our last one, F. Okay, looking at F, I'm looking to see if I can factor my quadratic. What multiplies to negative 16 adds to negative 8. Excuse me, adds to negative 6. It's going to be negative 8 and 2. So x minus 8, x plus 2. And then we're going to change this bottom. This shouldn't be a different variable. It should be an x. So it's 8 minus x on the bottom. 8 minus x on the bottom. Super tempting to cross out the x minus 8 and the 8 minus x, but we know that those are not equivalent, so we are actually already in a simplified version in the original. So this is our original final answer. So we would say, you know what, x squared minus 6x minus 16 divided by 8 minus x. And then we're going to say x cannot equal 8, because that would make that 0. And that is simplifying rational expressions. Hope this helps.